Hi students, in this video we're going to look at probability. Alright, so after watching this video you should be able to review, understand and recall the key terms of probability. So trial, sample space, event and outcome. Understand the possible values of probability and how they can be used to describe the probability of an event, usually using like a percentage or a fraction. And then calculate both experimental probability and theoretical probability for equally likely events. Alright, so before we begin, we need to understand some key words here. So a trial is just one single experiment. So if you're doing the outcomes of rolling a dice, one roll of the dice counts as one experiment or one trial. An outcome is a possible result of that experiment. So if you're rolling a dice, it's possible to get a 1 or a 2 or a 5. Those numbers are all possible outcomes. The sample space is just a list of all the possible outcomes, here contained in curvy brackets. So for your dice, you can get a 1, 2, 3, 4, 5, or 6. So list out all those outcomes in curvy brackets, and that's considered our sample space. Now for equally likely outcomes, that just means they have the same chance of occurring. So like with our dice, there's 6 different faces. They're all equally likely to be rolled and to occur. So each number, each part of the sample space has a 1 in 6 chance of occurring. An event is a collection of all favorable outcomes. So for example, if for our dice we want to find the probability of an even number being rolled, then the favorable outcomes, the numbers that are even, we could get a 2, a 4 or a 6, and those would be outcomes we would want to get if we're looking for even numbers. Now when we're calculating probability, the outcome of an event can be anywhere between 0 and 1, or between 0% chance of happening and 100% chance of happening. 0% chance would say that's impossible, that's definitely not going to happen. 100% chance means it's certain, it's definitely going to happen. Alright, a few formulas here. So the probability of an event in which outcomes are equally likely to occur is calculated using this formula. The probability of some event equals the number of favorable outcomes, so the number of outcomes that we want or that we're looking for, divided by the total number of outcomes. And that's what gives us our fraction or our number that's between 0 and 1. This bottom number, the total number of outcomes, should always be equal to or bigger than the number of favorable outcomes. So that's where we get our fraction or our percentage from. Now this formula we use for calculating what's called theoretical probability, because we're not actually doing any trials. We would just be knowing the event and knowing that the probability of each outcome is the same, and we don't need to do any experiments. So for our dice, let's say we wanted to find the probability of getting an even number. Well, the number of favorable outcomes, how many even numbers are there on a dice? Well, there's 3 equally likely outcomes, right? So the chances of getting a 2 or a 4 or a 6, they're all the same, right? They're all 1 in 6. So there's 3 favorable outcomes, and there's 6 different possible outcomes, 1, 2, 3, 4, 5, and 6. So the probability of our even number, when we roll a standard dice, is just 1 in 2 or 50%, because there's 3 possible outcomes that we want out of 6, and they're all equally likely. All right, now for experimental probability, it's the same. It looks like it's the same formula, right? But the only thing is, with experimental probability, we are doing trials and experiments to see what outcomes are occurring. So something where we don't know the probability of each event, or that events aren't all equally likely. We just want to work out what is the probability of something happening, and we do that by doing experiments and working out how many times does this event occur. We'll do an example of what that looks like in a minute. Alright, so in this example we're going to calculate some theoretical probability based on these spinners. Now for each of the spinners, all of these outcomes are equally likely. Now for number 2, we can make them equally likely by putting a little line through here with 4 equally likely outcomes. But all the others, they're all split into even equal shapes. So we can calculate our probability rather easily. So for the first one, the probability of getting a blue, well, there's 2 options and only one of them is blue. So our probability of blue for that first one is just 1 in 2. For the second one, we made that split, so now there's 4 possible outcomes, and again, only one of them is blue. For the third one, we've got 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, and 2 of them are blue. Then simplifying that, we can divide them both by 2, that's 1 in 4. Next, our fourth one, we've got 10 possible outcomes, and then we've got 1, 2, 3, 4 that are blue. So there's a 2 and 5 or a 40% chance of getting a blue with that fourth spinner. For the fifth one, there's 6 possible outcomes. Only one of them is blue, so it's a 1 in 6 chance. And then for the sixth one, there's 12 possible outcomes. They're all equal sized, so they're all equally likely. 2 of them are blue, which means once again there's a 1 in 6 probability of that outcome happening. All right, for our next one, now this is an example of experimental probability. So we've got people ordering mains at a Thai restaurant, and we don't know the probability of someone picking chicken just by thinking about the problem. We need data, we need information. So we're given some information here. Now we have to determine the probability, PR, of someone ordering chicken. All right, so the probability of someone ordering chicken, well, we've got 10 people ordering 10 mains that have chicken in them. And then in total, we have 19, 25, 30, 36. So doing that as a fraction, we can simplify that. There's a 5 in 18 chance that the next main that's ordered is going to have chicken in it. All right, determine the probability that there is no beef or tofu in the next main. So probability of no beef or tofu in the next main. Well, looking at this one, we just want to pick out the numbers that aren't beef or tofu. So we've got 10 and 6 is 16, 5 is 21. We're skipping tofu, we don't want tofu. Fish, that's 23, and prawns, that's 24. So now our probability of no beef or tofu, there's 24 options that are neither beef or tofu. And so it's 24 out of 36. We can divide both of those numbers by 12, and you get a 2 in 3 chance that the next main doesn't have beef or tofu in it. All right, this last one, if there's 40 mains ordered the next day, how many would you expect to be made of pork? All right, now this one here, we need to find the probability of someone having a pork main. So that's 6 out of 36. So there's our pork number, and out of 36 options. Now, if there are 40 mains ordered, we're going to take that number, 6 out of 36, and times that by 40. And then what we get is a number of 40 over 6 as a fraction, which is 6.6 recurring. So how many mains will we expect to make with pork if we've got 40 that we're making the next day? We can say that's going to be between 6 and 7. Right? So maybe 7 because our number will round up, but it's going to be somewhere between 6 and 7. We could expect around that many. 6.6 doesn't make sense. You can only have a whole number of mains. So that's why we'll say probably between 6 and 7, more likely 7. Right, so after watching this video, you should be able to review the key terms of probability involving trial, sample space, event, and outcome, understand the values of probability and how they describe the probability of an outcome, and then calculate theoretical probability for equally likely events, with that in the first example with the spinners, and then calculate and apply experimental probability with that in the second example.